look good? Yeah, right.
Ready when you are.
I'm ready, that's fine.
If you could just start out by telling us your name, title, and your company.
Sure. Sal Skideri, and I'm president of the company, and the company name is the Skideri Group.
All right, great. If you could tell us a little bit about the innovation that you have here at the World Congress this year and how you see it changing the auto industry.
Sure. We have a new engine concept. We call it a split cycle engine, where what we've done is we've actually separated the high pressure strokes of compression and power. So half the engine actually functions like an air compressor, and the other side functions like an internal combustion engine. It's really a new thermodynamic process where we're actually able to get more of the energy that's in the fuel to the crankshaft on the engine. So our design gives you an engine that's more efficient, and with our final configuration, we believe that we're going to be able to be in the range of 25 to 50% more efficient. It burns cleaner, our NOx levels are much lower, and it actually has the torque of a diesel engine. So it has a lot of very good features that help to solve many of the issues that they're currently dealing with in the industry.
Can you tell or elaborate a little bit about how it's different than maybe some of the other internal combustion engines that are on the market?
Sure, certainly. The biggest difference is that we actually have a different thermodynamic process. If you look at how our combustion process works, we do a thing called firing after top dead center. In other words, the combustion process does not initiate until the power cylinder is actually on its way down, and it's quite a long ways down. It's like about 14 to 15 degrees after top dead center. A conventional engine using either the Otto cycle or diesel cycle processes fire prior to top dead center, and that's before top dead center. The major differences between those designs is that you have actually a unique thermodynamic process which is able to convert more of the energy from fuel to mechanical.
Can you tell us a little bit about the innovation process, like that whatever you're comfortable with sharing? Like, how long does it take you to develop this product? And I see that you have a prototype. Is that?
Yeah.
Talk a little bit about that.
Certainly. The process takes a long time. It's fairly expensive. We've been at this for about 7-8 years now. We have our first prototype that just fired up June 25th. We have a very extensive research team that covers several companies in this country as well as overseas. We've actually spent tens of millions of dollars to get to this point. And it's a good, straightforward engineering approach that we've always taken, where we do a lot of analysis up front prior to building the hardware, and then when we build the hardware, we go through a very systematic test procedure to make sure that the performance is as predicted. But it is a typical engine development that takes a long time and a lot of money.
One last question. Can you, sorry, lost my train of thought. Can you talk about some of the challenges you see with bringing this to market?
Certainly. With any new engine development, there's always the concern of how it's going to impact things like the manufacturing processes of the current designs, whether it requires new infrastructure to be put into place. Fortunately, in our particular situation, we use all standard components. We don't have any exotic materials, and we're still really preserving the piston technology, where you have a crankshaft connected to pistons using connecting rods. So, I mean, we have a bit of an advantage in the sense that the manufacturing processes stay relatively consistent. We use standard fuels, whether it's gasoline or diesel, so there's very little infrastructure changes needed with us. But, I mean, those are the typical issues that you have to overcome when you're trying to introduce any kind of new technology.
Great. In closing, is there anything you'd like to share with us about your company, your technology, any other, last thoughts you want to?
Well, I mean, our design has always been focused at trying to get a more efficient engine. We believe we've been able to accomplish that by, the new thermodynamic process. It reduces fuel consumption and CO2 emissions. But really, the best way to really get to know about our engine is probably to look at our website, which is SkideriGroup.com.
All right. Well, thank you so much.
Thank you.